Welcome to a new test and teardown video. We're still playing with homebrew equipment, instrument and whatnot. Look at this one I just packed up. Wow, that is some funny thing. I really got no clue. What is this? I mean, please have a look and see if you can figure this out. That will be multi-turn pot meters, those two, and then 1, 2, 3, 1, 1, 2, 3, oh, 4, and a lot more. This just clicks all the way around. A normal pot, and like 1, 2, 3, 4, 5. What the? We got 2 B and C connectors, maybe on off. Let's have a look at the back. So here we got a few clues on the back. Counter is probably an output, right? So that would be the frequency something. Is this a sweep? First LO and then video. Say, I actually start to think I maybe know what this is. Are you getting somewhere in your brain? Okay, so if this is video, it could be you're connecting this to an oscilloscope. So those 3 goes to an oscilloscope, and this goes to a frequency counter. So that means this may be a front end to a spectrum analyzer, an analog spectrum analyzer that uses a scope. So I think we set some sweep frequencies here and some different frequency ranges and stuff. I'm really sad there's no text written whatsoever on the front. And this will probably be the frequency start, stop something, and then that will be the input. This is really a heavy unit, so it's probably packed with stuff. It's like really. I think we should try and power it up and see if we can figure out what it is and what it does from the outside first, because that will be a funny challenge, right? Let's try and power it up. Let's see if we can figure this out. So that's 16 watts. Okay, and this is counting. Okay, so this is fine. Ooh, what is it doing? So that is something. Ooh, okay, here we got some more. Right, so this one, that, ooh. That is weird. So that will be megahertz probably, right? Oh, it comes the other way. Aha! Slibbity slabbity. And then it... I don't know. I think this is megahertz, right? How about if we put this to 100? I don't exactly understand. This one is also affecting this. Maybe there's a marker or something. What is going on here? La. The funky buttons. Well, let's try and hook up a scope and then see what happens. So now we are looking at the video output See, that has something to do with sensitivity or bandwidth. Look at that, huh? There's definitely some stuff going on here that is related to video, the frequency, and this will be all sorts of megahertz. Because let's look at the first local oscillator output. So now I've connected to the first local oscillator output, and so that's 300 megahertz. No, 200, I don't know. All sorts of different megahertz, and it's also affected by this. So this is definitely the sweep. So I mean, I feel more and more confident this is indeed a spectrum analyzer front end. But I don't understand the sweep. It seems like the sweep is maybe external. So this is because there's nothing coming out of the sweep. I don't know if you can see this, but this is the frequency counter output. It's just absolutely random noise, but I think, yeah, I think the frequencies we see here is actually the video bandwidth, and when you input something, it will come out here, and then you'll be able to measure the frequency of the signal you are measuring. So that makes sense. And we are inside. I've been poking around with this. I'm just not able to make it do anything intelligent from the outside. But I really think that I was right in my assumptions. This is indeed a spectrum analyzer. And here it is. 0 to 200 megahertz input. The VCO is this one. It is sweeping from 250 to 450. So that is the 200 megahertz span. So that means the VCO input goes into the mixer, and together with the input, we'll have the first IF is 250. So this 250 goes through the first filter. And then it goes to the second mixer. So that means the 250 and the 260.7 makes 10.7. And then we are back to normal, right? And then the 10.7 is probably going into this one, right? And we got some crystals and stuff. And obviously we got some different crystals and different settings for different bandwidth. So that is obviously what we have in here. I can't wait to open some of this stuff and have a look. And what have we got in here? So there's probably 2 inputs. Why are we having 2 different inputs? But I think we should be able to figure this out, right? So this is what it's doing so far. Ooh, there's another. Oh, there's a hidden compartment. Look at that, all that stuff. Ooh, what is in there? Some more goodies. And we got some different settings. What exactly is this doing? I don't understand about this sweep. Are we sweeping, or is it coming from the outside? Because center, digital voltmeter. Maybe that is what it is. DVM, right? So this has something to do with the sweep, but we don't get any sweep. So maybe this thing was defect for a long time, and it was just in the shack for fun, for nostalgic reasons. But I really would like to see if I can figure this out. We don't get any kind of sweep out. So why is that missing? Or is it supposed to come from the outside? I really haven't got a clue. We got lots of other stuff in here. I mean, we need to open this and see what is in there, right? I think I found one problem. See, here's the capacitor. I don't know if you can see this, but there's definitely capacitor puke right here. See? A little spit drop from that one. And this is what we need to look for. So maybe this... Ooh, look at that. It is completely puked. Ooh, not good. That can't be good. That's probably one problem. And what else have we got of problems? Let's see if we can... Oh, now we need to play 3D Tetris again. How do we get this up? And why have we got this little funky thing here? Is this necessary for the amusement of the designer? That is such a trick. What is the hang on, I need to put down the phone and see if I can figure this out. I can't be that stupid. Okay, there was absolutely a magic way to do this, but I'm not going to reveal this because then you're absolutely going to say I'm stupid. Oy, oy, oy. It is full of sexy shit, man. So calibrators. Ah, so you can turn on and off. So that means when you turn this on, you're gonna see 50 megahertz stripes, right? We got some more amps. We got... Oh, this looks a lot like it's quite professionally made. So is this a kit? Or is this, you know, somebody who just designed this out of their head? This looks a little bit too much pro. A lot of modifications done to the... So this is a voltmeter that is used to indicate some start-stop frequency stuff, perhaps. I think it's about time we'll open some of these cans and have a look, right? Oh, I love it. This is absolutely worth every penny. Look how beautiful that is made. Wow. So this is a 50 megahertz calibrator. Look at the power supply and the power supply filtration. Whoa. I love it. And here's the 50 megahertz coming out. And filters and stuff. That will be the screws that mount this. Let's just follow this wire and put it on the spectrum analyzer and see if everything is alive. I think it's going to be a lot of fun to try and boot this up and see if we can make this work. Look what they've done. So there's a shielded cable here that shields to this case, and then there is another shielded coax in here. So that means this dude was doing double isolation and filtration and stuff. He was going for the last dB in this unit, and I like that. It is beautiful. We're going to look inside some of the other cans, but let's power it up and find all the voltages. See if there's like voltages missing. We've already found one cap that is completely blown up. I mean, there's probably more caps. Let's look at this one. It looks like it's also been, yep. There was also some puke. Also on this one, right? I don't know. Yeah, this can't be good. I'm feeling kind of this puyo. I'm just writing on the boxes as we go along here. So that will be the input. And this, we see here some relays, really beautifully made with attenuators. So those are relays you control with the 3 voltages here, so you can attenuate the input. So this is your input and it goes via this filter. Of course, this is a filter that handles so you can't input any more or any higher frequencies. So this will be a low pass filter from 0 to 200 megahertz. Otherwise you're going to see it's going to be a wrap around if you input anything higher because of the VCO frequencies. This will on this point to this mixer, the mixer here will handle gigahertz, so you'll just have everything will repeat itself every 200 megahertz again and again and again forever. So of course you need this filter so you know what you see on the screen is actually there in the real world, right? And this is what this filter does. And this one is IF attenuators. So we got 3 relays, and now they can of course be bigger and cheaper, more simple relays, because this is only 10 megahertz. And then it goes via those 3 attenuators to the rest of the stuff on the other side. Let's look a little bit more careful into all the different units. This is the first mixer. And here's the input from the filter, the 200 megahertz low pass filter. It goes directly into the mixer. This is the 12 volt supply. Look how it goes via all those filters, and then it's distributed, and then there's another filter, feed through, filter, feed through, and then the injection amplifier. There's even a tiny little coax feeding the mixer injection, and then the output goes to a little amplifier and a filter, and then it's inside the coax, and then even again another shielded cable, and then it goes to a 250 megahertz helix filter. So a helix filter consists of little coils in here, and then this is a resonator or capacitor you trim in for the correct resonance between each of these, and there's actually a hole in the wall in between them, so there's this coupling you want between them. This is a Storno filter from a VHF radio, and I'm sure he cut a few windings of each of the coils and assembled it again and fine-tuned this filter so it can be used for 250. And this is also revealed by the height of the trimmers, because they're normally all the way in. So I've been playing around with those filters a lot when I was a kid, so that's why I know. So the 250 goes to the second mixer. And see, that will be the labels of those 2 units. So this is a 260.7 megahertz local oscillator, and it's actually this way. So the output is here, plenty of output power drive, and this is made via a crystal and some doublers and triplers and a power amplifier, and then it's fed into the second mixer. So it says here 260.7 megahertz LO input, and then we get 10.7 megahertz output, and it's also 12 volts here. So the output got to be that one. So there's also a little filter after the mixer, a little amplifier and a filter, and then I think this is a ceramic filter, and then there is another amplifier and a filter, and then it goes to this section. And this consists of, let me show you guys this. That will be the IF amp, second IF amp. So that will be crystal filters. And I think some of this contains some sort of a switching system via those cables, where you turn on and off some of the different transistors and stuff in here, probably via some diode switching and something like that. It is really beautiful, beautiful handwork here. Look how it's really nicely made. And then there's a ceramic filter. So we got those 3 different filters, and this also corresponds to the different bandwidth settings. And then the IF goes to the IF attenuator block, and then it goes to the other side. Meanwhile, I've been, now it's upside down, of course. Let me flip the unit a little bit. Oh, let me see if I can, oh, this is bad, hang on. Meanwhile, I've been playing a little bit around with this. So I've been, every time I figure something out, I add a little bit of text to the front, just using a permanent marker to start with. Of course, this was the easiest to figure out the RF input attenuator. And you can even hear the relays, so that was easy to figure out. This is connected to the input attenuator, and then there's the IF attenuator block, and then there's the bandwidth settings, and this select between the 3 different filters. So first it's only one of them, and then all 3 of them. And if we look at the local oscillator, now I can't touch any of these buttons because they're affecting the oscillator, the VCO, and that VCO is running at 339.35 la 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 la, as you see here. So that is the output on the back of this unit, and as you can see, there is no sweep. This is just standing still, so this is in 0 span, as you can see. And the green one here, that is actually the video output on the back. So now if I turn on and off my signal generator, obviously we need to go for 250 megahertz, right? That was the first filter. So that is, you take 339 blah 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 minus 250, and then you find this frequency. So input this frequency, and I just input a lot of signal so I can play with the input attenuator. Oh, let me turn on the, here we go. So now we got some signal. See? Now we can play with the input attenuator. Now we can play with the IF attenuator. And then we can play with the bandwidth. And now the signal is gone because, see? Let me show you in 100 kilohertz bandwidth. When I dial the frequency here, woo. See? And then I need to be very accurate. And if I go to 3 kilohertz, it's just crazy. See? Super critical. What you see here is just the noise on the pot and all that, right? Ooh. So this proves the entire analog end and all that stuff is actually working. All we need now is to make this thing sweep. And look what I found. Of course I replaced this, well, let's just turn off the power. I of course replaced the capacitor that puked all over the place here. And that one, see that wire? That one is probably mounted in that hole right there. And it fell out. maybe that is what is causing the sweep not to work, because this is probably the sweep generator, and I think all those different diodes and stuff here is related to make the sweep handle the VCO behavior. So when this sweep is going in like a triangle like this, then what is the output to the VCO in different voltage ranges? Of course you need to linearize this using all those pots, and then you can fine tune, and that means the frequency sweep will now be the way you want it. So this is of course a totally don't touch, but it's made in a very nice and analog way to compensate for this. Today you will just use a microcontroller and do a software calibration, but here this is all analog, right? So I bet this is the sweep, right? Or is this inside or is this outside, or what is it? Because I see some center and I see a digital voltmeter here. I'm of course going to measure a little bit here and play a little bit with it. I got all the voltages, they're all okay. So let's play. So now I'm playing a little bit more around inside here. So this is the, I think this is a lock amp for IF, and this makes the video output, because this over here is definitely the video output. Also I found we got 2 coax cables on that, and one of them goes to, oh, let me see, can I get some light on this? On this switch. So this one is the video filter. So now I'm starting to write some more text on the front, and this is of course the cal output, 50 megahertz, 0 dBm. So we're getting closer and closer, and the rest here is associated with the sweep, and that just still don't work at all. And I haven't figured out exactly why this is not going to work. I did connect that missing wire, and it still just is not going to happen. This output is the output that goes directly to the VCO. So this is an output. And now I'm going to start to figure out what is connected to what, where's the input, where's the output, and so on. But come on, we got 3 op amps. It can't be that difficult. After a lot of research, a few hours later, well, it's getting dark and late and whatnot, I actually did figure this out. This is definitely a project that is dropped for some reason, because the external sweep input is connected to something here that is completely wrong, that is not connected down to the sweep input. And here we got a lot of resistors where you can set the minimum and maximum and ranges and all that kind of stuff depending on your input. However, it's not connected. So there's just a capacitor here, and this wire was supposed to be connected to something, but it is not. So it will never be able to sweep. So that is why this thing cannot sweep. So what I did is I simply just connected some sweep here. Well, I'm just going back and forward, but doesn't really matter for the sweep. So we got some sweep here, and I'm now looking at the video input, and I still got the same frequency at the input. So what I think we should be able to do is set up the scope in XY mode, right? So I want you to see the scope in XY mode. And of course we got a spectrum analyzer. Let's play a little bit with the input frequency. Let me go, this is a 105 megahertz. Let me jump 1 megahertz down. And one more. See? That will be all the megahertz I'm jumping down. Let me go down to the center. Why is it reacting like that? Of course we got a lot of loose relays, by the way. So now I'm down to 90 megahertz, and let me play a little bit with the, yeah, it's this, that will be the bandwidth switch. So this is the widest, 100 kilo. Let's go to 10, and let's go to 1. Isn't that just cute? So that would be the bandwidth settings. Let me play with the attenuators. So this is IF. Okay. I think we got a little bit of DC stuff. Okay. Yep. And then RF attenuation. I think I need to move this quite a lot. Okay, this needs to be in auto mode, obviously. Yeah, and then the IF filters. That is a lot of fun. This. So that is the RF input attenuator. But I mean, this thing actually works. And that will be, let's play with the video filter. Yeah, that works too. So that is the high video filter, medium, and off. Okay, that helps a little bit on the background noise. That is funny to play with a homemade spectrum analyzer from 70, 80, super old stuff. I mean, that is super cute, isn't it? I'm quite happy that I got this back to life. So yeah, it is definitely working. You just need external sweep, and just need to figure out how to input the sweep. And so far, it's just marked here with the sweep. The sweep input here is just not connected correctly. So that's basically it. And a little bit of context cleaning here, and then we will be back and operating for another 50 years. So I guess I will close this video and say thank you very much for watching.